Hello everyone, I am Bharat Singla and welcome to CodeChef. Here you'll find everything to learn and master competitive programming. So you know the drill with YouTube. If you have not subscribed yet, then make sure to subscribe to the channel to not miss any of the future videos. Great. Welcome to the last video of graphs. So today we'll be discussing a classic problem on graph traversal. So this is a problem solving video and the problem's name is number of islands, which is a variation of a very popular problem of a very popular and an integral concept in graphs, that is to count the number of connected components. So just to give you some history, like if this is the graph, right? So it may not be that all of them are connected, right? It may be that this is the graph, right? So this is a whole graph, right, where it is not necessary that every node is connected. So here what you have to report is the number of connected components. So this is a connected component, this is a connected component, this is a connected component, as well as this is a connected component, right? So in such a graph you have to report 4. So this is also a classic problem based on its variation, that you are given a matrix of size n cross n and you need to find the number of islands. So a 1 denotes land and a 0 denotes water. So it's obvious that if two pieces of land are adjacent to each other, they can be indirectly merged, right? So the number of islands come out to be these groups, right? So this is one island, right? Because they are connected blocks of land which are adjacent to each other, right? So this is one big island, then this is another island, right? And this, although only one, but still is an island, right? So the number of groups of land, this is what you have to find in this given grid. So the idea is to convert it into a graph problem. So clearly, as we have talked about as well, that a matrix is also nothing but a form of a graph, where each cell I comma j, right, is indirectly connected to the cell I minus 1 comma j, right? It's above neighbor, the one above it, right? Then you also have I plus 1 comma j, right? The one below it on the next row. Then you have I comma j minus 1, right? The left neighbor. And you also have I comma j plus 1, which is the right neighbor. So that's how you can form that if a cell is a node, then it's connected to 4 other nodes. And this way we'll keep on traversing the graph. So the approach is pretty simple. It's completely implementation based, that you take any one and you kind of spread outwards, right? You keep on visiting all the nodes that are also land, that are also one, and if they are adjacent, you traverse them. And in one traversal, right, from a one, you will traverse to all its neighbors, right? And from there you will traverse to all other neighbors and so on. Right, this way you will cover a full connected component, and then you can maybe mark it visited, that you, so you do not consider them again. Then you go on some other one and you again spread and do a traversal on the matrix, and then mark all the ones in its component as visited or something like that. Then you go on the next one which is not visited yet, you mark all its neighbors visited. And so basically the number of times you do this is simply the number of islands. Like for example, here you come to one, right? Then you go to its neighbor, this one is also one, then here, then here, then here, then here. You traverse. You can either use DFS or BFS. We are going to use DFS today because it's much easier to implement. And once you've done this, you will kind of mark all of them visited, right? So you do not consider them again. So you can either convert this one to 0, right? You can maintain a visited array. You can convert this to any other dummy character like dollar or something like that. And this way you have marked all of its all the ones in it component, right? Then you come to, let's say, any other one. So this is the next one which is not visited. This is the only one, so you cover this as well, right? So this is also no more a one. And then you come to this one. From this one you will go to this one and mark all of them. So this way you did it 3 times, so there are 3 number of islands, right? So this is the problem, and now let us directly move on to the code, right? You'll understand it better then. Okay, so the first thing is to take the input. So you have n as well as n, right? And after that you have a vector of character, right? which let's say we name as grid of size n with n rows filled with vector of characters of size m. Right, so this is a 2D matrix of size n cross m of characters, and now it's time to run a loop. Right, then you run another loop for the columns, and you input grid of I of j. Right, fine. So you have taken the input now, and after this, what you'll do is you'll again run a loop on the matrix. So I can just copy this loop here, right? And this time, what you do is you check if that cell is a 1. So you say that if grid of I of j is a 1, right? So that is a land, and from here you can start your DFS. Right, so after this, what you will do is you will DFS from I comma j, right? This is the starting point, and you can also increment answer, right? Answer denotes the final answer, the number of islands. So you can say that answer is initially 0, and in the end, you have to simply output answer. Cool. So now it's time to implement the DFS function. So like you can take the grid as a global array, right? Or you can pass grid as a reference, so it does not take a lot of time to your DFS function. But the best way to do is to simply, so this is, I'll be using a lot of advanced concepts of C++ as well. So this would be more of educational based as well, right? I'll not just be implementing it, but also showing you some really cool C++ tricks, right? So advanced C++ will be covered, and one of them is to write lambda functions, because they can be defined inside the body of another function. They do not necessarily have to be global functions, right? So this way we do not have to pass anything to the DFS function, not the grid, not n, not m, nothing, only I comma j, which are necessary, right? So I'll write auto DFS is equals to, right, a square bracket in which we'll take all the variables in this function as reference. So grid and all of them are now captured by this, and we have the starting point as well as the, and we have the starting points coordinate. So here now it's everything, now it's exactly the same as writing anything, like you have void dfs int I comma int j, right? And whatever you write inside here, inside this point, is simply the one what you will write here. Cool. So let's remove this. And okay, so here what you'll do is you'll first mark grid of phi of j as visitor. So another cool trick in graph traversals, you do not need another 2D array to say that if visited of I and j is true or false. What you can simply do is set grid of phi of j to the dummy sign, the way we saw in the explanation, right? So this is a dummy character, and this in a way implies that next time this condition will not be met, right? So this is, instead of maintaining an auxiliary data structure to save if a cell is visited or not, we can save some space, in fact a lot of space, because it's an n cross m grid, right? The visited array will be n cross m size, so that's a lot of space. We do not need that. We can change stuff in place. So this dollar indirectly represents if a cell is already visited, right? So I have visited this cell, right? And now I want to traverse on all its neighbors. So I have from I comma j, I plus 1 comma j, I minus 1 comma j. Then you have I comma j minus 1, I comma j plus 1. So you will have to do a lot of repetitive stuff, right? So I will not do that. I will instead create a vector of pair of int comma int, right? And let's name it directions, and I'll assign it to uh, okay, so I'll have 4 directions, right? The one which is from minus 1 comma 0, right? Then the next one is 1 comma 0, the next one is 0 comma minus 1, and the next one is uh, 0 comma 1, right? So what this means is that this is the neighbor above it, right? So what this means is that if I add minus 1 to my current I, so it is I minus 1, and I add 0 to j. So this is the new cell is now the above neighbor, right? Which is I minus 1 comma j. This is I plus 1 comma j. This is I comma j minus 1, right? And this is I comma j plus 1. So this way we don't have to copy paste stuff. And now what we can simply do is we can, another advanced concept in C++, that is object destructuring. So what I'll say is di and dj in directions, right? This way you don't have to go on every pair and then take pair dot first, pair dot second. You can directly destructure it here. And now my new cell, so my new I coordinate will be simply I plus di, and my new j coordinate will be simply j plus dj, right? So in the first iteration, when di is -1 and dj is 0, it will, my new I becomes I plus -1, I plus dj, which is I minus 1, and new j becomes j plus 0, which is j, right? So this way, in 4 iterations of this loop, I'll be able to cover 4 of the neighbors. So these are my new coordinates, and I'll simply DFS on them, right? So I'll visit them. After this, I guess this is enough. You just mark something as visited, right? Then you find the new coordinates and then you DFS. But here's the constraint. You you always do not have to DFS, right? If that cell is surely one, because you are calling from DFS from that cell if it's one, but its neighbor also have to be one, right? Where are we checking that? So we'll have to check that. So if some condition is met, that is if grid of new I of new j, so a new position, is also a 1, right? But here's another constraint. What if I'm on this cell? If I'm on this cell, this means that my left neighbor and my top neighbor do not even exist. They are out of the range of this point, right? So we'll have to check that as well, if our new position is even within the grid. So for that, we'll have to put in a lot of conditions. Let's create a function for that. So if inside uh, new I, new j, right, and remember to put this inside function before this check, obviously, because then it's no benefit, right? You have to put this before checking if that cell is one or not, because you first need to check that if that is even within the boundary of grid, right? Otherwise this will directly raise an error. Grid of new I could be -1 as well, right? If I'm already on 0th row and I go on its above neighbor, that is -1. So because these conditions work on short circuiting, so if this is valid, only then this will be processed. Otherwise, it will break here as simply, because AND needs both of them to be true, right? If this is false, this won't get evaluated. So another advanced concept. So make sure to put it before, right? After have this condition, otherwise it will raise an error. And yes, we are cool. Oh, we have to implement within inside function as well. So I can say that auto, this is another lambda function that I'm creating. Auto inside is equal, again taking everything by reference. So I have to return if I is greater or equals 0 and I is less than, I is 0 is less than equals I and I is less than equals n minus 1, and 0 is less than equals j, and j is less than equals m minus 1. Right, so this is my full condition to check if I comma j is within the grid. Cool. So I guess this should be enough, right? Although, oh, I guess this will raise an error. Like you cannot use auto here because DFS is a recursive function, right? So this should raise an error. Let's see what we get. Okay. Oh, right. So we have to have this, right? So yes, use of DFS before deduction of auto. So auto basically automatically gets replaced with whatever is being returned. But here, since DFS does not even know what DFS inside of it will return, we have to specify the type, right? Here it's clear that it is a Boolean return, true or false. So auto will automatically change it to Boolean. But here we need to explicitly pass. So another advanced C++ concept, right? So this is actually what is behind auto. So this function, this is a function object that returns void and takes two int parameters, right? So if I run it now, yes, so this works perfectly fine. So this is the code, right? You take the input, then you have a function to check if it's within the grid, then you have 4 directions, right? Then the DFS function that first marks it dollar or even 0 would work. Yes, we again get, basically you want to convert a land to something else, so you do not consider it again, right? So it's best to replace it with a dummy character, right? And then you go on all the new directions, you check if it's inside, and that is a land as well. You DFS from there, right? And if you are feeling uncomfortable, then make sure to revise the DFS video. And after that, we simply, for any new one I find which has not been visited yet, I found a new island and I'll traverse from it, marking all its neighbors and all the ones in its component as dollar or something like that by doing a DFS. And finally, we print out the answer. Cool. So this is the code. And one thing I would also like to mention is that the most elegant solution would instead be of disjoint set union, but that is out of the scope of this video. Right, so we won't be discussing that. This is good enough, and this is a really good problem to revise all your graph concepts. So that's it for this problem, and that is also it for this video, and that is also it for this playlist. Thanks a lot for following along till the end, or lol if you just started from this one. But anyways, hope you liked it, and you know the drill with YouTube. Like the video, share the video with your friends, and comment down anything interesting you want me to read or ask any of the queries you have. This is Bharat Singla signing off for now, and I will see you next time.